Okay, so this is where we're going to start the scope of the variables. We know now that we have 3 integer data types, and we can create variables with those. We have the short, the int, and the long. And then we have 3 data types that we can use to create absolute numbers, which are the float, the double, and the long double. Then we have 2 that manipulate characters. One of them is a single character, and it's the char, C-H-A-R. And then we have the string that is going to be a list of characters. We also have the Boolean, which is going to be showing only 1 bit. And it's going to be, if it's on, it's going to determine true. If it's off, which is a 0, it's going to determine false. So we have this data types that we can use to create variables. And variables are going to be located in main memory, right? And everything that we are going to be processing must be there. Now, how long will the variables last? We call this the scope. They have a lifetime. So the variables are going to be, if they're going to be created in main, it's going to live, they're going to live within main only. And the best thing to think of this is that they live wherever they were created in that block of code. And the block of code is going to be determined by the curly braces. So that if I have in main, I have int, main, open and close, and I have this curly brace, and I put int x. This x, which is a variable, which is going to be a memory location, is going to last while the process is within this block. If later on we're going to be using inner curly braces or another block, and I put here int y. Y will only live right here. So we need to remember that. For right now, because we're only using one set of curly braces, our variables are going to be within this program, okay, within this block. Another thing that we need to keep in mind is that the variable cannot be used before it's defined. Remember, we already talked about this. So it's just a little note so that we remember that we have this right here. So we have, in this case, the example, they have int num1 is assigned the value of 5. So they are creating a box in main memory that is pointing right here. This is num1. And it's going to be an int, so that means it has what? 4, right? 4 different bytes. And in there they have a 5. So they have a 1, a 0, a 1, and then zeros. That's what they have. So now what we have here is now num is going to be display. So we're displaying a number 5. In this one, we're saying display number 2. Do we have a number 2? No. We don't have that location in memory. So this one has to be before the cout, where we're displaying num. Okay, questions?
Basically just the way to save memory, right?
It's reserving memory. Yes, it's reserving memory. And remember, the name of the variable is the pointer, right? It's pointing at this location. This location is saying this slot, this row, this column. Yes?
My question is, so the second set of curly braces on int-y, do you use int-y first?
Can I use int-y? You're referring to this one, right? Right here. Yeah. If I put int-y outside this set of curly braces, then I can use y here and x here as well, because they are going to be outside. So it's like the outer loop or the outer block controls everything else. But if I define it right here, then it will only live within this block.
So X can be used in the Y, but Y can be used in the X.
Exactly. X can be used inside the block where we define Y, but Y cannot be used outside that smaller block. And we call that the scope. It's the part of the program where the variable may be used. Okay? So we say X has a larger scope than Y, because Y, it's only limited to this section right here. But X can live anywhere between these two. So that means if we have another set of curly braces inside, that's also where X can live. Any other question? Okay, we're going to start with the arithmetic operators. We use arithmetic operators to perform calculations: addition, subtraction, multiplication, division. And we call this operators. We're going to see how we have unary operators are going to be when we have like a negative number. What this is going to tell the CPU, it's multiply of 5 times a negative 1. So that's the operation that is going to be performed. So we call this unary operands when we have a negative sign. When we have an arithmetic operator that is going to be indicating subtraction, multiplication, division, we call them binary because it's going to require 2 operands. So we have the addition, and I have 2 operands. The operands are going to be like if I have the X plus the Y, or 5 plus the variable Y. This is an operand, this is an operand, this is an operand, this is an operand. If I have multiplication, the same thing, I need 2 operands, right? If I put X minus Y, I also need 2 operands. If I have a division, I'm going to be needing 2 operands. So this is binary, is the type of operation that we have when we're working with arithmetic operators. Okay? Always, we need 2 operands if I'm going to be subtracting, multiplying, dividing, or adding. It's always going to require 2 values. I cannot add 1 value. It has to be 2. Right? If you say, well, I'm adding a 2. Yeah, okay, you're adding a 2 to what? You always have to add it to something else. You always have to multiply it by something else, by another value. You always have to subtract from another value. You always have to divide another value. So it's 2 operands is going to be a binary operation. Okay, we also have operations that are going to require more than 1. We're going to wait on this one later. Okay, but for right now, just so that you know, we have unary and we have binary. So these are the basic arithmetic operators. To add, we're going to be using the plus. To subtract, we're going to be using the hyphen. To indicate multiplication, we're going to be using the star or the asterisk. To indicate division, we're going to be using the slash, is the forward slash. And to indicate modulus, this is an operation that is a division, but the result is going to be the remainder of that operation. So that if I'm going to be dividing 4 divided by 3, what is the remainder here? How many times will 3 go into 4? 1 time. Okay, so this is 3 remainder, 1. So this is what is going, the result of the modulus is going to be 1. If I divide this, 4 divided by 3, then it's going to be, the result of this operation is going to be, if it's division, it's going to be 1.333333, right? Which is very different from just 1. So if the addition, I don't think we have any problem. If I'm going to be adding two variables, if I'm going to be adding two constants, if I'm going to be adding a combination of variables and constants. If I'm going to be subtracting, the same thing. If I'm going to be multiplying, the same thing. But when we are dividing, okay, when we are dividing, it's going to be very important what type of operands we're using. If I am dividing two integers, like in this case, the 13 divided by 5. Because I'm dividing two integers, my result is going to be an integer. If I do this operation, 13 divided by 5, it's 2 times. Okay, yes, but this is, I'm dividing two constants here. I can force them to be floats. If I put an f, then that will make a difference. But if I don't have the f, they are two integers, right? So what happens is this is going to be divided. 2 times 5 is going to be 10. The remainder is 3. And it's going to stop right here because you say, okay, I don't need to continue my division because this is an integer. This is an integer, so the memory location that I'm going to be using to store the result that is going to come back from the arithmetic and logic unit is going to be an integer. So I use a 2, and 2 is going to be stored in memory. No name, because we're not using a variable to hold this value. Okay? It's just going to give us a 2, and that 2 is going to be in memory, and that's what we're going to be displaying here in the cout. This one, the same thing. Cout, the result of this division. 2 divided by 4. 2 divided by 4. How many times will 4 go into 2? None, right? 0. So we have 0 times 4 is 0. Remainder is 2. If we will continue this, it will be 0.5, right? That will be the result. But because this is two integers, then it's going to display just the 0, not the fraction. The same thing with this one, not the fraction. It will truncate the fraction. If I have this 13 divided by 5.0, right here, 13 divided by 5.0, then the fraction is going to come out. The fraction is going, this is very different. This is a 2 and this is a 2.6. And even if it's a 0.0001, we want that fraction to show. Because maybe that is going to be used for a calculation for an interest, it's going to be used for calculation of taxes, it's going to be used for the measurement of a substance, and it's very, very important, that 0.0001. The same thing if comparing this to cout. I have 2 divided by 4. These are integers, and these are now, the first one is going to be a floating point number, and this is an integer. So it's going to display 0.5 instead of a 0. Like I say, for the addition and for the subtraction, we have no problem. Or multiplication. Division is going to be different, so we have to be very careful on which type of operands we're using. Now, the modulus, I already explained. The modulus, it computes the remainder resulting from the integer division. But the remainder is never going to be a decimal. It's always going to be an integer. And so it's always going to be requiring that we use integers. So we have 9 divided by 2. 9 divided by 2, this we have 4. 4 times 2 is 8. The remainder is 1. So this is going to be the result of this one. Displays a 1. when we have one of them is going to be a floating number, this is going to be an error. Questions? Okay. One last thing that we have in this chapter. Remember when we write comments in our programs, we use the double slash. And that is a single line. If I want to have another line, I have to use again the double slash, right? And then write my comment. Well, we have another method that we can use. And that is when we use the slash with an asterisk. I can start slash asterisk and I can write the definition for my program and then continue in the next line without the double slash and then continue another line and then continue another line. So I have 1, 2, 3, 4, and then when I'm ending my comment, I can just put asterisk and then the slash. It's like the reverse. So this is marking the beginning of my comment and this is marking the end of my comment. And this will enclose more than one line. So now we have two methods. In this case, they are showing us here, they start, asterisk, the slash and the asterisk, they are going to be putting a line with dashes. Here is a multiple line comment now, and here is another line with dashes, and it closes with the slash, but before the slash, they have the asterisk. Yes, it's a forward slash. Can also be used in a single line if we need to do that instead of the double slash. Okay, with this we close chapter 2. Okay, so we're going to start another practice exercise, and it's going to be in the first program that we have in chapter 2. Okay, so we're going to open up our Pearson so we can open up the book. No, I have to open up the text, right? Work on program number 1, the sum of two numbers. So we're going to read the project and then we're going to come up with our definition. We're going to visualize the output and we're going to create a plan using a pseudocode so that we can solve this. So this is, let's see, what are they asking here? Write a program that stores the integers 62 and 92 in variables and stores the sum of this 2 in a variable called total. Display the total on the screen. So what do they want? Stores?
Integer
62 and 99, okay. Where do we store them? In variables, right? What else are we going to be doing here? Okay, and we're going to display the total. What total? Of the two values. So what we're doing here in this description is just rewriting, right, to see if that's really what they're asking us. If we want to try to understand what the project is about. What do we want to accomplish? So in this program, we're going to store two integers, a 62 and a 99, in variables. Then we're going to display the total of the calculation, right, of the two values. Okay, so let's see, how are we going to have the output? What do we want to have on the screen? What are we going to display? A total, right? So just a number? We don't know, right? So I'm going to put just numbers. 9999. Is that what we want? Yes? That's it? You don't want a message saying what this 9999 is about? Okay, so we can put here a message, right? Do you want it on the same line or before? Before? So we're going to put the what? The what? The total is, how about a colon? And then the value on the next line, 9999. Okay? This is what you have to decide. Okay? You're the programmer. They just told us, right? Oh, I want a program that adds these two numbers are going to be in variables, and I want the display, the total display on the screen. And we have to think, okay, I can put just a number. I can put a message. The message can be right next to the value, or the message can be on the previous line. I want to put after the number, I can write, thank you for using this program. Something like that. Or I want to put my initials. Okay, this program was coded by so-and-so. Do we want to display the date? We have to think of all this. And that's what the visualization is. And then, of course, if this was a project that we were assigned, we will need to take it to our supervisor and say, okay, is this what you want? Is this how you want the output? Do I change it? Do you approve it? And then when we have the okay, then we're ready to start, okay, how am I going to do it?
What's the page number?
This is page number 63. So now we're ready to start the pseudocode. It was already approved. This is the way that they want it. The output, so we're ready to start our pseudocode. So what will be the first step that we need? So let's call the directives, right? What directives do we need? IO stream. Okay, so I need IO stream. Do I need another one? No, that's it. I don't need the string, right? I'm not going to be using any strings. So variable strings. I'm going to be using a constant, a string constant, but not a variable string. Okay, so I call the directive IO stream. By calling it, this is not going to give me the total is 9999. Okay, so now I need to open the memory locations. How many memory locations do we need before I write anything? We need 3. One is, I'm going to put here, variables. I need one for the 62, so I'm going to call this number 1. Okay, will that be fine? And what data type do we need? It's an integer. And this one is going to have a value of 62, right? The next one, can we call it number 2? What type do we need? Also an integer, right? And this one is going to have the value of 99. Because we already know the values. They are giving us the values. So we have to use, they told us use 62, use 69. That's why we're using those numbers. Then the third one, I'm going to call it result. What type are we going to be using for this one? So what result are we going to have? Yeah, but what data type? It's going to be an integer, it's going to be a fraction, it's going to be a letter, it's going to be a string of letters. It's integer. What value are we going to start with? 0. I want to put a 0 in there because I don't know what I'm going to get. So these are my 3 variables. Okay, so I already have them in main memory. So now, excuse me? The equation. What equation? Okay, I need to do the addition, right? I need to perform my calculation. So it's going to be calculate the result by adding number 1 plus number 2. That's what I want, right? Okay, so I did the calculation. The calculation happens in arithmetic and logic unit, and the result is going to be placed in main memory. Do we see it at this point? Not yet. What do I need to do to see it? Display. What am I going to display? Okay, I'm going to display first this message. The total is, I'm going to put here display 2 lines. First line is going to have the total is colon 1 space and then we end. And what else do we display? Whatever we have in result. Whatever we have in result. Do we need to do anything else? End. Perfect. So now we're ready. If we check this, this is going to work. So we call the IO stream because we're going to be displaying. We create 3 variables. The first one is going to be an integer, is going to be called number 1, and is going to have an initial value of 62. The second one is going to be an integer, is going to be a number 2, that's the name, and it's going to have an initial value of 99. The third one, it's an integer, is going to be called result, and it's going to have an initial value of 0. Then we're going to add number 1 plus number 2, and the result of that operation is going to be placed in the memory location that we already have that has a 0, but it's going to replace the new value, right? The 0 is gone and we have a new value. Then we're going to display one line, which is going to have the total is, and then display a second line where we're going to bring whatever that result that we place in main memory, and we're going to put it out. And I think we will get this screen right here. So now we're ready. We checked the pseudocode. We think that it works. So we're ready to start now our Visual Studio environment so that we can create our C++ program. Okay, so we start new project. We want to make sure that we have Win32 console application. I'm going to call this Chapter 2 PROG 1. Section 1. Chapter 2, Program 1. And I use the 01. Underscore 01 for this section, for this class. This is going to be next. I want to make sure that I use console application and empty project. You always want to check that your folders are empty. Remember, they will show here if they have something in it with a plus. If we have a plus, then you went into the creation of your Visual Studio incorrectly. Okay. So now we go to Chapter 2, Program 1, right-click. We add new item. Code, C++ file. And it's going to have the same name, Chapter 2 PROG 1 underscore 01. And I'm going to add. So now the only one that has a file is source files. So we're ready to start. Okay, I'm going to follow my pseudocode. So the first thing that I have is my comment, right? So I'm going to use now the new method that I learned today. Asterisk, the slash and the asterisk. Let me make it bigger. There we go. The slash and the asterisk. So, and I have here my description, right, in my plan. So I'm going to copy it, and I'm going to use that. Add it here. I'm going to put it into lines. And then at the end, I'm also going to write today's date. So it's September 22, 2016. And then the next is programmer. And it's your name. And this is the end of the fourth line, right? So we're going to close it with asterisk and the slash. So now we're ready to start our program. So following the pseudocode, I have first call the directive IOStream. How do I call a directive in C++? The hashtag and then include open, right, the angle, brackets, and then put IOStream, close it, using, this is the only one, so write it after that line, I put using namespace, std, semicolon. So I'm done with line number 1. Line number 2, I have variables, num1, num2, and result. Number 1, number 2, and result, and I have all the information there. So how do I create the first one, integer number 2, and has a 62 in C++? How do I indicate that this is an integer data type? int, we have to start with our program, main, open and close parentheses, and then I use my curly braces, right? And now we can start our program. So we can start int, number 1. How do I put a 62 in that variable location? Okay, is the operator that is called assignment operator. 62, and then close the statement. The next line, the same thing, int is going to be called number 2, and it's going to start with the value of 99. I'm following exactly what I have here in number 2 in my pseudocode. Number 2, here's number 1, number 2. And then the next one is going to be int, is result. And it's going to have a 0 value, right? Okay, so I'm done with step number 2. Now I go to step number 3 here in my pseudocode. So calculate the result by adding number 1 plus number 2. So that, how do I write this in C++ language? Number 1 plus number 2 just like that? Okay. Okay, we need the assignment operator, right? We need the operation, but we need a place to put the result. So we are going to use result. It's assign the value of number 1 plus number 2, and then we end the statement. Remember what happens here. Whatever I have to the right of the equal sign is going to be executed first. So number 1 plus number 2. Control unit sees that it's a plus. It says, oh, it's an addition. Who does this? Oh, arithmetic and logic unit. Calls on them. They do it. They do the addition. And they say, okay, here's the result of what the operation that you asked me. and then control units grabs that result and is going to put it in memory right here in result. Yes, I'm going to be changing it in a minute, and we're going to see how we can rewrite this differently. Yes. It will work. The way that you have it, it will work. So now let's go to number 4. And after we finish this one, and this is going to be like the long version, very detailed, and then we're going to start modifying this. So let's see. I have the result now in main memory. What do I need to do? I already have it here. In step number 4, I have to display 2 lines. So I'm going to display Cout. The total is and then on the next line, so I have to skip a line, I'm going to Cout. What do I display? Result, the variable result. And then skip another line, just so that we don't have the press any key to continue. And then we have the end. How do I end in C++? Return 0, and we're done. So we're going to run this, Control F5, and see if it works. Okay, let's wait for this. Did you run your? It works? Yes? So now it's just my computer that it's taking its time. Okay. Yeah, it doesn't make any difference. It's going to take its time. It's coming up. There it is. The total is on one line, and then 161 on the next line, which is what we wanted here in our plan. So we know that if we add the number 62 plus the 99, this is going to be our result. We didn't have any problems converting from pseudocode to code, right? No problem. That's why I'm always reminding you, you have to plan before you start coding. Okay, so now let's see. Let's go back now to our code. We're going to work with this. We already know that this works, but we're going to see different ways that we can write this out. Okay, first, Victor, you have 1. Okay. Okay. So instead of putting a 0 in result, what we can do is get number 1 and number 2, the addition, and put it right here. Will that work? Yes, it's exactly the same thing. What we're doing here, it's again saying, okay, number 1 is going to have a value of 62. So it's going to be assigned that value. Number 2 is going to have a value of 99. So it's going to have that value. And result is going to have the value of the addition of number 1 plus number 2. I didn't mean to do that. There we go. To number 2. And it's going, this addition is going to take place first, again, in the arithmetic and the logic unit, and the result is going to be placed in result. What we can have here, okay, the problem that we can have is that we can have trash in result. But that trash is going to be sent away because the new value is going to be that addition. And then we're going to be here displaying. Can we rewrite this Couts? Yes. In a single line, right? So instead of having the Cout right here, I can remove it. And we're making it shorter, right? And we have exactly the same thing. The total is, and then end line, result, and end line. Even though it's in one statement, it will display in 2 different lines. One more change that I want to do. When we have variables that have the same data type, like in this one, number 1 has one data type, int is the data type. Number 2, it's an int as well. And result, it's an int as well. I can separate them, or I can use a comma to indicate, hey, the next one, it's also an int. I'm going to remove this. And the name is num. And the next one, it's also an int. And the name is result. And we can have it this way. So I don't have to list int number 1, int number 2, int result. They're all ints, so they can be listed on the same statement without repeating the int, because they are the same data type. So C++ can read our instruction this way. So look at how many lines I have now. 2 lines of code. Instead of how many I had before? 3, 4, 5, 6 lines. And I reduced my program to 2. Let's try it. Let's see if it works. Hopefully this time will go a little bit faster. You got it already?
Yeah, but instead of the result, that number 1 plus number 2, I put a 0, I put a 0, and it gave me the result as 0. That's because I'm saying it's 0, right?
Exactly. Yes, if you have result with a 0, then the 0 is what we have in that memory location, and that's what you're going to get. You need to add number 1 plus number 2 and place it in result. Okay, so there it is. The total is 161, and then press any key to continue. Will it make a difference if I move this line and I put it here? Will it make a difference? Yes. Why? I haven't assigned to number 1 the 62. I haven't assigned to number 2 the 99. So it's going to say, hey, wait.
But that's only if you add the like if you were to move that down and then keep the semicolon there and not on top.
Exactly, that's what I'm, if I move it on top, That was my question. If I move it before, then it's going to make a difference. So we cannot do that. Okay, any other question?